It's nice to see so many friends. And I'm John Palmesino, and together with Anne-Sophia Cook, I'm the co-founder and director of Territorial Agency, and among other things, I convene Diploma 4, and I teach in the History and Critical Thinking MA. Territorial Agency is an organization that combines architecture, art, science, advocacy and action. And this evening we discussed with Mike what we could bring to the table to discussion for the Climate Matters week. And we wanted to really start a discussion about what we think is a condition that is paradoxical or baffling for architecture. And that is really the rise of the Anthropocene. This is a LiDAR scan of Crawford Lake. Crawford Lake is a tiny, weeny little lake in the metropolitan region of Toronto in Canada. And in that little lake, at the bottom of that lake, which is a very steep side, at the bottom of the lake in the strata, scientists have identified a spike in the isotopes of uranium, which is associated with the explosions of the nuclear tests of the late 40s and early 50s and the hydrogen bombs of the 50s. The spike in that isotope is not only in that very isolated part of the planet. Nobody touches the bottom of the lake, and it's completely isolated. No, it's really a difficult space to imagine that it has been tampered by humans. But at the bottom of the lake, there's a spike. But it's the same isotopes are everywhere. They are in your teeth, in your hair, in the bones that keep you up. It's everywhere. This is the ultra-rapid rise, in geological time, it's less than an eye blink, of the new condition of the Earth. It has emerged very quickly, and of course, it's really 1950, early 50s. It's the beginning of the new epoch of the Anthropocene. The Anthropocene is, of course, a very contested word. Nobody agrees on who's the anthros in that. Nobody knows who is in charge of such a disaster, or is it a disaster, is it an opportunity? And this is something that I would like to leave at the side for the moment. But I really like you to think that the spike at the bottom of that lake is the marker of a condition that we've created. Maybe not you, because you're all young. You might think that you haven't contributed to it. You might think that you are innocent. But actually, since the end of the pandemic, you might be surprised. We've contributed to the Anthropocene strata almost as much as between 1950 and when I was born in the 70s. In the last year and a half, as much as all the time until 1970, since 1950. 20 years, 2 years. So you might not be that innocent as you think. And this is really the challenging condition. So tonight I would like to explain how the appearance of this new geological moment, it's a moment in the history of Earth, is challenging for architecture. I'd like to bring it back really to our conditions here tonight at the Architectural Association, trying to understand what it really means. As you see, the lake is this hole. It's a black hole. In reality, the most beautiful part of this image is what you don't see, is what the science sees, is what the instrumented knowledge of science is. But let me bring you very quickly to understand why Crawford Lake might be the global boundary stratotype section and point, or otherwise the golden spike of the Anthropocene. This has been a very complex process through which the stratigraphers, that is, geologists who study how the strata, which is the bottom of the sea or the bottom of the lake every year, and it accumulates because leaves and frogs and dead birds accumulate down there. No, that's the strata. They're really puzzled and as much lost as we are by the notion of the Anthropocene, because the notion of the Anthropocene doesn't originate in geology. It originates in a completely different set of sciences, which are the earth sciences, in particular earth system sciences. In the year 2000, a hero of ours, and I think one of the heroes of the 20th century, Professor Paul Crutzen, a Nobel Prize for Chemistry, atmospheric chemistry, famously stood up in a meeting and said that the epoch that all his fellow scientists were studying in the convening of the International Biosphere Program, which was an international program to coordinate hundreds, if not thousands, of scientists understanding the relationship between life and the lithosphere and the atmosphere. He stood up famously and said, "We are no longer in the Holocene. We are in the Anthropocene." And since then, everybody's shocked, everybody doesn't know what to do. And a group of friends and scientists and then started seeing whether it made sense for them, whether it made sense for the stratigraphers to understand the Anthropocene, which was very quickly becoming a concept that was circulating in scientist circuit that were far away from stratigraphy, but also in social sciences, in the humanities, in the arts. And they started debating. And this is a long time ago, like 10 years ago, this image. And this image is something that we've organized. I might put down the sound here, you don't need to.
In terms of their impact. And what we are looking for as the boundary is a really significant step up in activity that's recorded in all sorts of different ways by the kinds of soils that there are, the amount of nitrogen in the environment, the carbon dioxide in the ice cores, lead from burning petrol, all of these things. And they are massive jumps, really massive jumps. They make what now is happening really distinctly different from those prior eras thousands of years ago.
Absolute precision in boundary is impossible here. So what one is looking at is where the mistake is the least. Where the mistake is.
Okay. That was a meeting that Territorial Agency organized. It was the first meeting of the Anthropocene Working Group. In the meantime, above that beautiful room in the House of World Cultures, in this beautiful Congress Center built by the Americans as a gift to what was then West Berlin to show off modern capacity. In the meantime, all the philosophers, all the artists, all the humanities were quickly dismissing the Anthropocene, saying it's not possible. No, we should consider new forms of anthropology. We need to really understand that there's no such thing as man. And when you're talking about age of man, who is it? Why is it a white man? Why are the people in there all men and white and middle-aged? It's just that not so many young women are so keen on stratigraphy, maybe. But the interesting thing is that the humanities quickly dismissed the Anthropocene, while the scientists had not even started their work. And that was almost 9 years ago. 9 years ago in 2 days. In the meantime, the Anthropocene Working Group has managed to put together a lot of work. And they've basically are trying to change this This is the International Chronostratigraphic Chart, which is the history of the Earth. And every single line in there is debated by hundreds of scientists, and each one wants to move a little bit the line further up because they discovered in a particular cave that something is happening, or they move, they take some of those colors and they merge them because they have a different theory, and this is the work of science. Science, in geological terms, is the very complex history of the planet. And as detectives, the stratigraphers try to understand what has happened, and they try to understand basically the relationship between life and the Earth. The Anthropocene Working Group deals with this thing. Sorry that it's a little bit sharp, maybe you see it better in this. We are in the Quaternary period. The Pleistocene has given away its structures to the Holocene, and after the last glaciation, the Holocene has dominated the planet. The Holocene is what you study at school. No, it's the erosion of the valleys. It's how rivers run through the valley and erode the fields and organize the entire structures of the world as you know it. The Anthropocene will be an epoch. So it will not be an age or a stage. It will be an epoch, and there's scientific consensus on this. It will not be a period. There's no scientific consensus on that yet. It might be that in a few decades, it might be even considered an eon. We don't know yet. This has to do with evolution of life, with the structures. So what is it that they're really trying to do is define that little line. This is the Anthropocene epoch. 50 years in 4.5 billion years history of our planet. 50 years against 4.5 billion. And the puzzling thing about the Anthropocene epoch, and this is really where I would like to take the discussion by going through some of the work that we have been operating, is that that line is completely changing the relationships that we have with what we thought was an inert background. It's completely changing the way we sense who we are and where we are, not to mention when we are. So the Anthropocene epoch is baffling architecture because as a new figure in the making, the figure that somehow underpins the notion of the Anthropocene, that new figure, we think that we are completely in charge of. And it's made up of things that we've designed. It's made up of things that a lot of architects have designed. Designers have made that. And it's made up of cities, it's made up of buildings, infrastructures, industrial systems, information systems, and so on and so forth. So from within the technosphere, which is a beautiful concept by Peter Haff, who's a fantastic paleontologist and engineer, we think that we can simply design it better. No? And I think that we've spent 1.5 days now we are 1.5 days into climate matters. We think that we can design it better. The physical condition is that the material, energy, and information fluxes that characterize the technosphere, which is made up of everything that keeps humanity alive. So basically me, I think that there are a couple of 100 people on the planet that are not in the technosphere. Everything that you eat, domesticated animals, domesticated plants, tofu, fish, the trawling of the seabed, the energy system that fuel that, and the technology that we have, the information systems. Information systems are called, they used to be called universities, archives, libraries, and unions of workers. Today you might think of the internet. It's more than that. All of that together is the technosphere. It's full of chicken. It's full of pigs. It's full of soybeans. And all together, we think we can design it better. But the baffling element is really this. That, let's put it like this, that the current rush of architectural practices to align themselves with discourses on what many people will call the climate crisis, I call it climate chaos, is always reverted to discourses of distribution of labor, imperialism, colonialism, senses of guilt, we heard that a few times, notions that are ultimately, while they recognize that the earth is a self-organizing entity, they are ultimately trying to bring back the discourse to the Holocene, to a human-centered structure. While the technosphere, the Anthropocene, is now a new component of the earth. Hence, it's self-organizing. It's quasi-autonomous. We are not in charge. Its dynamics are propelled by completely different systems than the ones that we can imagine. We endeavor to maintain the technosphere rather than the other way around. We thought that technology, architecture was there to extend our capacity and free us, liberate us, like the vacuum cleaner liberates women. It's not like that. You become entrapped in layers and layers and layers and layers and layers and layers and layers of design that are completely intersecting all the other so-called spheres of the Earth. The lithosphere, the hydrosphere, the atmosphere, and most importantly, the biosphere. They are everywhere. These spheres, it's a horrible name, but because they're not real spheres, are everywhere. Wherever you will look, you find all of them. And this is really the puzzling condition today. The Anthropocene is puzzling because we are becoming alert to this new figure, the new Earth, and at the same time, we revert to an Earth that we have long abandoned, that of the stable climate of the Holocene. And so at Territorial Agency, we are really thinking that this condition is an aesthetic condition. And we really need to engage with this appearance of a new figure through aesthetics, by combining, I think, what architecture does best. Apart from conviviality and hospitality, architecture does the best when it combines science, technology, and art. When it makes the world apparent. And this is where we work. So a little scheme. This is a beautiful diagram that we lifted from Tim Lenton. Tim Lenton was here when we did in the previous life, Plan the Planet, a series of debates around the condition of planning and the climate chaos. Here you see the lithosphere, land, the hydrosphere, the ocean, and the atmosphere. And they are more or less in chemical balance. The atmosphere is a very strange thing. It's full of oxygen and it's full of methane. If you think carefully about the atmosphere, the hydrogen is highly combustible and the oxygen ignites the atmosphere. We are in a planet that is highly off balance, but more or less, it stays. It doesn't blow up. Now, the technosphere is this. Is a new interference in that. And it really has to do with the fact that we have an incredible capacity of burning fossil fuels. Fossil fuels is a word that is difficult to understand. It's easier to call it petroleum, carbon, biomass, sometimes gas. And that's what keeps the technosphere running. It's the propellant of the technosphere. It's petroleum, fossil fuels. Now, that thing is what keeps us alive. And it's a new component of the Earth. But differently from the biosphere, it doesn't recycle. We'll come back to this, how the biosphere recycles. The technosphere, in its explosive rise, very quick rise, has left behind a huge amount of what I would call debris. My phone, but also debris in the sky. What we've been debating yesterday, carbon. It's debris of the technosphere. It's debris of our technology that keeps us alive. It doesn't come out of the blue. It comes from land use change. It comes from burning fossil fuels. And the preoccupation, of course, of all the scientists is that all of that debris is not captured back by life. It's not recycling. As simple as that. You might hear many times, we have to recycle this and that. What you are actually hearing is we have to reuse. A recycling structure undoes a material and recirculates it across the Earth. So this is the baffling element. And I would really like to spend a little bit of time, maybe this evening, to understand this new figure. It's a very big thing. Many of you know we have this interesting hobby. We measure how big the technosphere is. No? We measure how heavy buildings are, but we measure how heavy cities are, how heavy is the ocean, Anthropocene, and so on. And back of the envelope calculation, which is actually more than a back of the envelope, it's a scientific paper that we published with the Anthropocene Working Group now already 8 years ago, makes it 30 trillion tons. 30 trillion tons is a lot of zeros. A ton is 1,000 kilos, a cubic meter of water. 30 trillion of those. I still don't understand how much that is. 30 trillion tons is the equivalent of, and this is in the sky, in the ocean, in the forest, in the cities, it's everywhere, no? It's even in us. 30 trillion tons is the equivalent of 28 centimeters of rubble everywhere. Everywhere. It's made up of many materials. Many of them are really complex, like the things that are in your phones that you carry around, this thing, these things are really complicated materials. And we call them technofossils. The technosphere, on many levels, is the trace fossil of humanity. It's the traces that we leave on the planet. You know, like dinosaurs left some traces in the mud and they became fossilized. We leave behind all of this. If you take all the carbon that has been emitted since the beginning of the Industrial Revolution, so the anthropogenic carbon that is still in the atmosphere, and it will be there for a few 100,000 years, around 250,000 years. And you put it at only CO2, let's imagine only CO2, at sea level pressure, it's the height of my sun. It's this high. And it grows. It grows faster than my son. He's 8. It grows faster than a little kiddo. 1 millimeter every 2 weeks. Why? It's not by automatically. It's because of us. So we think that we can stop it. We can think that we can retract, no, pull the handbrake, except that if you think about it, when we did pull the handbrake, because of the moment when we started understanding the planet in a completely different way, where the virus was going from mouth to mouth and very quickly spreading, and that was another moment of becoming aware of the planet, we had a little drop. And then it went up again. And now, after 1.5 years, it's further up than it was before. The acceleration continues. So if of those of you who are really into Excel sheets, the technosphere, back of the envelope calculation is urban areas, rural housing, rural roads, railways, cropland, pasture, land and eroded soil, plantation forests, reservoirs, and troll seafloor. These are just categories that are useful because they appear in global cartography. And if you make the sum of the surfaces, you have them there, the area in millions of square kilometers, urban areas 3.7, it's quite big, pasture land 33.5. The thickness we evaluated of the urban area, more or less 2 meters, if you compact everything, like they're doing now in Gaza. If you compact everything and you kill everyone, 2 meters. The density is 1.5, which makes it 11.1 trillion tons. So it's a back of the envelope calculation. This is what I wanted to really to think. And of course I mentioned the war, because war is a major propellant of the technosphere. Think only that the largest oil consumers are the military. Now, the technosphere is baffling also for another reason. The technosphere is baffling because in order to see it, in order to start being sensitive to it, we need technology. We need a lot of technology. And we have technology. We have technologies orbiting our planet. We have technologies well beyond orbital structures. We have exited the solar system. The technosphere is well beyond the solar system. We have sensors that are flying, and then they kill you. We have sensors that are in every room, in every street. We have sensors at the level of the waves, and we have sensors in the forest, we have sensors beneath the waves, and we have sensors at the bottom of the ocean. And that part of the information fluxes you usually don't consider when you think of the internet, but it's around twice as large in terms of data as your tweeting and Instagramming and so on. So technology we have. And in order to see the technosphere, the technology that we're using is really interesting, is the same technology that causes the technosphere to be propelled. It's the extractive technology. Ecological thought has, no wonder, a military origin. The same dimensions. The structures of becoming aware of climate change, the weather forecasting are military. The supercomputers are there because of the military system. They're not there because of weather forecasting first, and then we can use a fantastic machine also to prepare the atomic bomb. No, it's the other way around. That's the first difficulty. So we can see the technosphere. I warn you for some flash photography. Those of you who suffer might want to close their eyes. We have multiple capacity to see things across time. This is fishing in the, I think, in the Pacific over 1 year. This is sensors orbiting over the English Channel, and those little white dots are the boats, full of people and goods and materials. It's really difficult to understand it. You need a capacity of computation to do that. But through technology, you don't see the technosphere alone. What you see is exactly what these images show, is variations over time. You don't see the planet through technology. Many of you know that we use satellites instead of pencils at Territorial Agency and in Deep 4. No? But you don't see the planet. You see accumulation. What you miss is the fact that when you do see the planet, you are in a new situation that has never existed before, that makes everyone on the planet, every living entity, in the same situation. No matter whether you're a little bird, or a worm, or an advanced scholar, when there's a storm, you're now perceiving the planet. It's no longer a local phenomenon. You are always perceiving the planet. And the new planet, the new technosphere, the added energy in the planet is exactly this new condition. And it's baffling because it's by location. You need the technology, you need the view from nowhere, the God's point of view, and you're completely located. So you are in two places simultaneously when you're perceiving the Anthropocene. And this is the second element of baffling condition, which is typically a spatial dimension. And those of you who might be more interested in the complex history of the relationship between architecture and cosmology might understand that the relationship between location and bilocation is at the crux of the transformation of European architecture in the 15th century, and the rise of the structures of what we call today the Renaissance. The impossibility of locating oneself versus the cosmos brings about the entire reorganization of what we call models and the maquettes. The technosphere is also baffling because it's the inversion of figure and ground. We think that we are the active side and everything else is the background, inert, stand still, and a lot of the designs in architecture really makes it stand still. In this room and these buildings, they also design cities that move, but they didn't really work. But mainly, we think that the architectural dimension is figure ground, and the ground is, what is it that they call it? Landscape. We used to call it nature. Now, what is interesting of the technosphere is that it then does completely that, because you can no longer distinguish whether it's the forest being completely transformed by the hydrological power plant, in this case in the Telemark in Norway, or whether the hydrological dam is the technosphere, while the changing erosion in the Alta River Valley is not. No, the Anthropocene tells us that it's both, but we think it's the dam, the object. So you see, this is the interesting element of thinking the Anthropocene as a sensorial condition, as a condition of aesthetics. Because suddenly we are dealing with both an object and a subject, like our friend Emanuele Coccia would say. It's a systematic inversion, and it flips. And it's not only what you might think as the urban or the hinterland. No, there's so many of our colleagues who are now obsessed with the global urbanization, the extension of the hinterland everywhere. But the interesting thing is not just the transformation of, let's say, what used to be the country, the countryside, agriculture, into the technosphere. But it's also what is not cultivated that is the technosphere. It's the extinctions. It's the extinctions of animals, it's the extinctions of practices, the extinctions of cultures, mainly material cultures for humans, and so on and so forth. So again, this question of figure ground is baffling. And what is even more baffling, at least for us, is that it's not only ground-based. It's really intersecting the sky, the ocean, the bottom of the ocean. And so this is really where I wanted to open the discussion. I know it's getting already late for you, but I will continue. So, when you have the inversion of figure ground, I'll use a word that is used often here, agency. Do you have agency? Which I think is usually misunderstood. Everything has agency. Everyone has agency. The agency is the capacity to act, and many things act. Whether you feel empowered is a different thing. Whether you feel in charge is a completely different thing. But there's an inversion of agency. Agency is no longer contained, it's distributed, it's networked. So the mid-sized goods that architecture operates with, a master plan, are no longer contained. They are networked. They network out and in at the same time. And it's really difficult to grasp because they're not only material networks, they are information networks, energy networks. So this is the beginning. Now I have a little bit of an idea of how to show you what we've been doing at Territorial Agency. And bear with me, and maybe we do a quick round of questions before I delve into new tools for public diplomacy. Do you have questions? Everything is so crystal clear. I'm so happy. Any questions? Do you want to take a break? No. Mike.
Okay. I have a question. I'm going to maybe take a second or two to formulate it. It used to be axiomatic in information theory that every data point was equal, that there were no significance to any particular one, and that significance was something that humans constructed from their reading of what is essentially a kind of neutral matrix of points. It was also axiomatic, I think still is not as contested as the first point, that every artifact of the world contains, if you could only replay it, the information of its formation. I think the classic example was given as the pebble in the stream, that if you could take the pebble out and replay all the forces that had acted on it, you'd go back to its original position in the mountain, and prior to that, to the magma of the mountain's formation and so forth. So I'm struck by the essential paradox of your argument.
Well, it's not a paradox. There's something called the arrow of time.
Yes.
What we are describing is mainly a historical dimension of the Earth. Those of us who love information theory like you are well aware of the notion of entropy. And I see our students in the room that have been working a lot on entropy. And the condition of entropy, McLuhan, or Shannon, or the entire debates that originated actually in these rooms around that notion that everything, and which was a structuralist idea, everything is message. And message is both connected to a matter, to the origin of the message. You need to know where the origin of that piece of data is, but it's also the carrier and the code and the decoding. And we always think that that is irreversible. But you are a little bit younger than I am, and you are aware that the structures of time are not completely irreversible. And this is really rising maybe in the 60s and 70s with the notion of complex theory. Ilya Prigogine in chemistry, the entire debates of cocoon in thinking structures, tipping points in Earth systems and world systems. So what we are describing is a move from a structuralist condition of understanding data to understand science as story, as history, storytelling as well. So I think this is where maybe the debate could articulate further in the week. What's the relationship between those modes of operation? Some of them have a really deep history in these rooms. Thinking of Pask upstairs, the entire possibility of thinking command and feedback. What is the role of scripting and designing? What is the role of a monument? Is it about history or is it about the future? I think those are debates that are carried really in the discovery of the Earth as an entity with history. But it's not the same Earth that was discovered by the first geologist in the 18th century. And the problem there was, how do you go from the periodization of the Earth being Monday, Tuesday, Wednesday, Sunday, Saturday? Friday was not clear what happened, maybe the flood, to the 4.5 billion years. Let's put it like this. It's a paradox that is beyond the Anthropocene. We know that there is a Big Bang. And we are pretty sure about that. So there's a history of the universe. But we have mathematical structures that imagine that we can go back. How is that possible? Is it because mathematics is not really part of nature? Is it part of culture? And there you see again the entire debates about rationality and scientific thought being trapped in the distinction between nature-culture. Or better, between the domain of freedom and the domain of necessity. Which I think is where I would like to have a debate, maybe later over beer. Did it answer? It's a great question, Mike. Thank you. Nacho.
So isn't the problem science then? Why are we keep on looking at science and not at philosophy or, I don't know, other...
No, because today you can no longer make that distinction. The scientists are a really interesting group of people. They have this instrumented and corrected knowledge. And we are holding on to science as, I hope, as treasure it. But they are at the same time telling us we should change our lives, which used to be the domain of the politicians. And that's interesting. Science is now full of people telling you what to do, how the world ought to be. They used to be telling you only how the world is. And they're really interesting people because of that. They're really amazing and passionate people that have a grasp of the difficult conditions of how to articulate a collective position. In science, there's something called consensus. In architecture, there's no such entity. There's scientific consensus on the anthropogenic origin of the technosphere or of climate change. There's scientific consensus. We don't even start thinking to collaborate. No, we call ourselves an association, and in here we all fight against each other. It's interesting, no? We don't have that notion. Another beer.
From the past two questions, I think my question starts much closer to time when we talk about the past 2 years, as you mentioned, that during the period of COVID, the spike kind of slowed down, but then again in the past 2 years, it kind of rapidly moved forward. And you just mentioned that there is a possibility of, because of the scientific research and the kind of recommendations the research shows to optimize or to reduce such impacts are possible. What do you think in the past 2 years, even when we saw that there was a decline in, let's say, there was an improvement in the air quality index in countries where, I mean, for that brief period, I come from New Delhi, and I've been experiencing air quality that has been more than 300, 350. But during the period of COVID, we saw the significant reduction in that. And we saw the reasons why it was being reduced, because of less vehicular movement, multiple factors such as that. And so there were clear evidences of such hard steps could make a significant impact, but somehow we still have managed to not learn anything from it and kind of spike back again. In your opinion, as in these sciences, what is the possible reason that we are still not taking adverse steps to kind of make an impact?
I'll come to that. I think it's a great question. Now, when the pandemic struck, the beginning, we were in Venice. And so we started looking at the lagoon, and we checked what was going on. And again, we have a lot of interest in satellite. The coastal areas became blue. It was interesting. The coastal areas around the world became more and more blue for a couple of months. And then they became green, and more green, and more green, and more green. Now, no, we have friends that say very clearly, I'm thinking of Anne McClintock or even Jeremy Jackson. It used to be the blue planet, now it's the green planet. Not because of green energy, but because of the algae. The runoff. I actually think that maybe the reason why there is no inversion in that curve have to do really with the fact that we're not in charge. And when we think that we're in charge, but I will come to that later if you bear with me, we think that we have to retreat, like in the pandemic. Oh, if only we would retreat like we did in the pandemic and we sit still at home. We even switch off Zoom. Maybe something might happen. But this is the baffling element that I didn't discuss, actually, of the Anthropocene, is that it has already happened. It's not something in the future. It has already happened. There is latency. There is locked-in energy. The carbon in the atmosphere is already there. It traps energy into the system. It's not going to go away overnight. And if you are interested in modeling and you go and visit climate modeling people, they spend a lot of money trying to understand what will happen if we switch off completely. How long will it take to reduce? Can we switch off for 2 years and then take a break? No, it doesn't work like that. There's feedback loops, both positive and negative, that are associated with that. And what really emerges is that the Earth that we're seeing is an Earth that is a complex system with multiple tipping points. I think that is the condition. It's not about being better boys and girls. Okay. Oh, more questions. I will never finish this lecture.
Sorry, it won't be a big one. So I just wondered what you think is do you see science and technology in the same sphere?
No.
No. So what do you mean by science when you're framing science?
Well, scientists are those who try to understand a phenomenon as it is emerging. And as it emerges, they try to understand causation. Technology is interested in diagrams. It's a diagrammatization of, a mathematization of what we used to call nature. It's a very different animal, very different agency. Technology multiplies and articulates networks. Science is about becoming sensitive very different structures. Technology is engineering. I'm not saying applied sciences, but engineering. And in contemporary terms, we think of technology in abstract terms. It's very interesting. Maybe the tech is algorithms. We never think of the material part of it. That's why I think that the notion of the technosphere, even though I don't like the sphere part of it, is interesting because it combines the farm with the algorithm, with the combustion engine, with the oil industry all together. And suddenly you have this figure that is, a little bit too big. So I think that there's a serious difference in that. Okay. It's going to be rushed, but what we do at Territorial Agency is this. We work like an architectural office. We get commissions. We look for commissions. And we operate with institutions, and we try to help them understand where they are and what are their territories. That means what are the conditions that maintain them alive and how they are influenced by them, not the other way around. Not how they influence their management and their technologies and their partnership, but how they are shaped by those structures. And we do this by combining science, art, advocacy, architecture, of course, and action. The idea is that when you finally have our partners on board, they start understanding that they're not where they thought they would be. So it's a prototypical architectural practice. We place our clients. We create a place for them. But how we do it is a little bit different from designing buildings where they can be in. We want them to understand that the level of coherence of the spaces they depend on really is now of a different order of magnitude, and that they need to seriously engage with that order of magnitude. And we start always with undoing the usual understanding of what is a territory, which is usually a national idea. And we start with entities or spaces that are dirty, that you don't know whether they are belonging to one domain or the other. We call them dirty cosmopolitical spaces. That's where we start. And this is really a tribute to Ulrich Beck, notion of Risikogesellschaft. What is that? The risks that pertain to a particular entity that we work with. The organizations we work with are very diverse. They go from individuals to families to different kind of organizations, like an art organization or an organization like Greenpeace or the European Commission or UNESCO. We work really in a strange way, and we embed our team in their practices. And usually our team is made by AA graduates, but not only. And so that's the general understanding. Is it more or less clear? It's typical placing of architecture. It's really, in that sense, and we think that we are really most boring architectural practice. What we do then is that we intercept Earth system analysis and world system analysis. World system is more complicated than Earth system. Earth system, you can imagine, is the interaction between biology, chemistry, physics, in order to understand the Earth. Is what the scientists will do, but world system. It should have a hyphen, but I cannot put two hyphens. The world system is the coherence of human cohabitation across time and space. And it's a concept that really originates from the 1950s, longue durée. It's the concept of Brodel, Emmanuel Wallerstein. It's really a concept that comes from economics intruding onto historiography. Maybe that will resonate with my HCT students, the role of history in understanding contemporary. In general terms, you can imagine it very simply. On one side, there's the clouds and the volcanoes and the oceans, currents, and on the other side, there's the infrastructures, economies, budgets, and so on. That is a nice distinction, but interestingly enough, you cannot really be serious in making that distinction. I hope that what I showed you so far makes you that distinction impossible. But this is still a duality that is so ingrained in the modern system. People will really understand, the budget, you have the Chancellor of the Exchequer, and then you have, who is it, the State Secretary for the Environment? They changed so many times. Someone deals with the dirty rivers, and two different things. In reality, we know very well that the two are in really difficult connection. Earth system, and by the way, we'll not go there today, is for the people that are a little bit weak in the heart. They don't dare to call it Gaia, but the Earth system is Gaia light. It's the world system. So this is what we do, and I'll show you now 4 projects over the last 15 years. So we've been doing this quite a lot. And what we've been doing before Territorial Agency was equally interesting, but it's a different life. It was dealing with classical notion of architecture and urbanization, and dealing with understanding the new urban condition and the urban phenomena of globalization. Work on Europe, the global city, the rise of Asian cities, cities on the move, mutations, and so on. In the Anthropocene Observatory, we look at people looking at the Anthropocene. This is just there as a reference for the Anthropocene. People looking at the Anthropocene are the United Nations Framework Convention on Climate Change, they are farmers, they are research centers, scientists, world leaders. No, the Anthropocene is now cutting across all areas. And what we are really interested in the Anthropocene Observatory is to create a documentation of that arrival of the Anthropocene on the practices. So we go to the IPCC, but we also go to
Les Français
UNFCCC.
So space has disappeared. We are sublunar, which is a completely new situation.
Bruno Latour.
And yet, the great discovery is that this is a new Earth in intensity, not in extension. So suddenly it has agencies. After having spent 3 centuries denying agencies to the Earth, to the object, and making it build of matters of fact and dry middle-sized goods, suddenly the Earth is back with agencies. Not as one, but full of agencies.
That was not only characterized by the financial and economic crisis that has, in a sense, preoccupied so many countries in the last few years, but also by the question of how will further science further accelerate the confidence, the momentum, and the willingness of countries to step beyond the current comfort zone of agreeing internationally on actions to respond to that scientific evidence.
So this is time, but I'm not sure what the scale is. It looks like it almost has to be daily.
Anthropocene Observatory was still is a collaboration with Anselm Franke.
Of course, the whole notion of the Anthropocene is that people are now a geological force, that we're causing changes as big as major geological events like meteors and so on have caused in the past.
Media scientists. And we're really working with photographer and filmmaker Armin Lincoln, understanding basically this. Now, how do you go from the reports on climate change, which are occupying an entire library, to the 100-page executive summary for policymakers. And how do you go from the executive summary for policymakers to an architect trying to do something about that? And we follow all of these traces and we try to document a deep transformation in science, a deep transformation in culture, where the culture-science divide is no longer possible. And what happens is that what emerges really is that science is telling you both that the world is made and it's a fact. And this is really the puzzling thing of the Anthropocene Observatory and how we then investigate, for instance, this Antarctica McMurdo base with all the militarization of the scientific exploration in Antarctica. And we accumulated around 200 interviews. Each one is filmed and tagged and analyzed, and we try to decipher the rise in discourse of the Anthropocene. And this was really at the basis of the structures of our engagement with the topic. Now, you all know that you saw it maybe yesterday with Earth Day. We need 7 planets. No? At the moment, we are using the equivalent of 7 planets. Now, we need to understand that we can only have 1. Either we give up the other 6, or we seriously engage in what we're best at as architect and design, and that is recomposing, composing that space, no? Where you have to be together and reorganizing that things. Now, that movement is a very complex one. At the moment, we are really interested in understanding that today it's the Earth that moves against the world. It interrupts your day. It stops you from landing at Heathrow. The storm that is approaching tomorrow will stop you from going shopping. It intrudes on you. And today, there's still only one answer. This is the only answer that humanity has until now to that intrusion. And it's what we call the logistical. More planning, more technology. And the obvious condition of adding technology to the technosphere in order to reduce the technosphere, I think is quite obviously an absurdity, but we are all endeavoring in this. And this is really where you understand how marginal science is. Everybody imagines the science as being completely powerful. Incredibly strong ideas don't have any impact. Now, the interesting thing is that in that more technology and more space planning, what we are really relating are 2 conditions. And so far, this has been the Holocene, where we would have a polity operating in a specific space, in a specific ecology. One group of people operating in one territory. A polity is a beautiful word, obviously comes from polis. The Romans translated into respublica. In English, I think it has to do with, it's more understood as the form of government, but it really is the city. The question is, how do you relate a city to its space? It's the most classical problem of what you might call your site. One to the other. And the question, of course, is that contemporary territories, that relationship between a polity and its spaces of operation, the material basis of operation, is rather unstable, and they're becoming planetary. And it's really difficult to engage with that planetary dimension. But here's where maybe you understand our name, territorial agents. Territory is not coming from terra. It comes from terrere. And the origin is quite obvious. No? The observatorium is the site out of which you observe. The laboratorium is the site of labor. The territorium is the site of terrere. And terrere is a beautiful word, deterrent, detergent, terror, which is up to date. That is the difficult thing to grasp. A territory is not an object outside. It's a semantic condition. It's a media conditions, information. It's how you warn people not to intrude onto you. It's how you protect what keeps you alive. This is where territorial agency becomes maybe interesting for you to understand. It's not just an office, it's the agency of territories. It's how they act on the entities that need to be maintained alive. And you remember that we have 7 planets and we need to recompose them. And the idea of that recomposition, many faces in the audience I recognize because they are our students, is really connected to a notion of a contract, to an association, to being together. Is what we might even call peace. It's the new natural contract of Michel Serres, but it's also the social contract. It's a problem of engaging architecture with politics, with conditions of shaping how we cohabit. Now, all of this, and this the second project, is connected to this. That cloud that you thought was just beautiful storm is associated with the territories of oil extraction. And we saw it, we discussed it earlier, the dip. No, this is the global energy used by humans. It's now in the orders of around 620 exajoules, or if you want to calculate it in terawatt hours, you can do your calculation, but the beginning is just at the same time as the AA. The AA has contributed in this story. Some of you might have heard this before. The renewables are that little piece on top. Now, this is the so-called hockey curve stick. We'll come to this again in a few minutes. The hockey curve stick is called the Great Acceleration. And it's a term coined by Will Steffen, who died last year. And he was a fantastic Australian climate scientist and modeler who most famously, you might have encountered his work in the notion of planetary boundaries. And Will Steffen is really at the origin of understanding that what is happening, and this is the beginning of the Anthropocene, is an acceleration of all entities that we can measure. You see, after 1950, the curve starts shooting up. And the difficulty, of course, if you want to go again in the baffling element, is that that line is seen by many still as development, as something good. It's the growth. Yeah? We have to grow, and growing is good. But like in a, what are they called, those images that sometimes you see the rabbit and sometimes you see the duck. It's optical illusion. And you see, it's baffling because you don't know, maybe it's the accumulation of bads, not the accumulation of goods. We don't know. But that growth is either the growth of good or bad. We don't know. And this is the really baffling condition of the Anthropocene. It's an optical illusion. It's a sensorial difficulty. You don't know what you're looking at. Many people still think that it's good to do it. And many people even imagine that it's bad only because it comes from the north, while the south is innocent and they can still develop. But then you think very quickly, what was Gandhi traveling on to liberate India? Steam engines. What did Kwame Nkrumah do? Oh, big dam. So you see, it's really interesting, but the notion of the Anthropocene is baffling also in terms of human disenfranchisement. The notion of possibility of aggression from oppression. Because everyone somehow contributes to it. Now, I will not bore you, but you've seen this hundreds of times. The same data in percentage, and you see the different energy forms giving shape to different cities, different forms of cities, different form of architecture, different forms of polity, and the relationship between polity and space that is at stake in the modern project. Wood, no, biomass, small communities next to each other, dense cities surrounded by countryside. Coal, you need a lot of bureaucracy. You need structures like ministry for extraction. You need the bureaucratic systems of parliaments to decide what to do and what not to do. The rise of oil at the beginning of World War II gives rise to the international. International is a beautiful neologism that was coined just down the road by people that were really into calculating the goods and the bad. The nuclear, the gas, and the global age. And then, of course, we hope that the renewables will give rise to a new cosmopolitan space. So this is the general framework of where we operate at Territorial Agency. You've seen Anthropocene Observatory intervene and try to understand and shape with that understanding also the public domain for the discussion on the Anthropocene. And here, a conceptual diagram. And this is where really the Museum of Oil with Greenpeace comes in. The Museum of Oil started here with Charlie Cronick and John Soven from Greenpeace coming after a talk to us and saying, maybe we can work on a project. And then we spent like 1 year discussing what the project could be. And the Museum of Oil is this behind the scenes project where we embed a team of Territorial Agency on the top floor of Greenpeace UK, which is up in Islington, in a beautiful building that used to be a site of animal experimentation. And the Museum of Oil has one goal, to help Greenpeace deal with its very complex research for the campaigns. And it starts with a very simple intuition that we shall need to keep oil in the ground. Everybody knows that we should keep oil in the ground. And at the same time, we all know that, should I keep oil in it? Why don't you start? And this is an impossibility because we know that oil is what keeps us going. We eat oil. We survive because we eat food that has been fertilized with nitrogen that has been extracted from the atmosphere through the complex refineries of oil. And what we did was to create for Greenpeace structures through which they could articulate the different campaigns, save the polar bear, save the Arctic tundra, save the Amazon, and you know that it's quite complicated, especially because Greenpeace is a small organization. It's quite complex to keep everything coherent. And the coherence was really given by the notion of the territories that were wrought by oil. So you need to keep oil in the ground, but you can't. So you need to have a space to negotiate how you will start. If you don't negotiate how you will start, you just push the can down in the high grass and never happen. So the Museum of Oil is a really strange space. It's a space of negotiation. We call it diplomatic encounters, where you start debating how to keep oil in the ground. And it combines Earth observation. For instance, it combines observation of places like this, that is Athabasca, the tar sands. I know that tar sands are going to be part of the program. This is the single largest industrial site in the world. It's in Alberta. There's a multi-temporal analysis. In blue is everything that was built in the last 5 years before the image was taken. And it's ginormous. And everybody imagines the largest single operation on the planet being what we need to. Just a couple of images from Greenpeace so that you have an idea what we're talking about. The tar sands is tar, which is this gluck. It's this muck of dark material that you use to make your boats waterproof, and it's mixed with sand. And it's in the boreal forest up in Canada. And the idea is that you scrape it, and then you work it out, and you refine it. As a side effect, you have a lot of sulfur. And then you pump the crude into pipelines that go across the plains of North America, notably the North Dakota pipeline, but not only, and they eventually reach Chicago or the Midwest, and you have refineries, and there you produce cleaning liquid. You put more energy into this than you get out. So we document this and we try to understand what's going on. We make all the analysis and we involve a lot of partners, how to understand what goes in there, what is that thing. It's impossible to photograph. But then we discover this. We discover that the tar sands are actually the smallest part of the system. The tar sands really rely on these cuts in the forest. Everybody knows about the deforestation in the Amazon. Nobody speaks really about the deforestation in the boreal forest. The boreal forest is deforested in little pathways at a time. And a truck goes along these pathways, and behind the truck there's a big hammer, bam, 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 and you create a eco sounding. No, it's a seismic sounding, and then you have very complex expert knowledge who receive a lot of money from the oil industry to study where the oil could be. And then they decide where to cut them and where to extract them. But no, these are images just to give you an idea of that little cut in the forest. And you might think, okay, it's just a little cut. No, it's minimum. The trees will grow very quickly back into it. But the interesting thing is that these lines are now in the hands, and the data is in the hands of the oil companies. It used to be that the data of the forest was in the hands of the environmental agencies. Now it's in the hands of the oil companies. And they cut the forest, and they cut the forest. And this is North America. It's everywhere. One little cut at a time. One little cut at a time. So then we analyze the structures of extraction, the conditions of what is a refinery. But here I would like you to pay attention, because it's not obvious. We heard over the last day, carbon, 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 carbon. Now, the difficulty in having to keep oil in the ground is that we think that oil needs to be kept in the ground because of carbon emissions. In reality, the major risk of keeping oil in the ground comes from oil invading every single structure of our lives. Oil has direct access to every prime minister. Oil has expanded economies. It has stretched so much that our economy, our very means of sustenance are becoming more and more volatile. And it has to do with this. RRR. It's a little riddle. What is RRR? It's reserve replacement ratio, which is the driver of the Anthropocene. The reserve replacement ratio, and you see there's no dot because we want to keep the last drop of oil for us. No? The reserve replacement ratio means this. If you have a field of oil and you pump out the oil, you are running out of reserves. And you might imagine that, then you become rich, run a nice, easy life in a ranch in Texas. But that's not how the oil industry operates. The oil industry operates through debt. Oil is a commodity that is very easy to extract. It costs nothing to extract oil. It's really the easiest thing in the world. Pump it out, sell it at incredible price. What happens is that while you're running out of reserves, your investors stop saying, oh, but you're not so interesting for me to invest in because your reserve is diminishing. I better go to your friend, and he has a lot of reserves, still unused, and I'll go to him. So what you start seeing is that you have to replace the reserves. You have to replenish the reserves. You cannot produce oil it takes billions of years. It's fossil fuel. No, it's fossil. It's fossilized biosphere. It took millions of years to form. So you have to find it somewhere else. You have to expand the research. You have to go in crazy places. You have to go in maddest, completely out of the scale places. You have to go in the tar sands, take it out from that muck. You have to go under the ice. You have to go in the pre-salt delta of the Amazon. You have to destroy completely the delta, the tropical delta of Panama or the Niger Delta. No, it's completely deranged. But what it does is that it attracts more and more investments. And the economy really brings up this thing. What is interesting, of course, and this is where you might understand why it's topical to discuss how to keep oil in the ground, is that all those investments are stranded assets. So what you thought was your asset for an economy, it's nothing. You thought that you had riches, and it's worthless because you can't burn it. Our economy is at major risk because it's based on oil. And it's a stranded asset. Our pensions, our hospitals are running on stranded assets, our military is running on stranded assets, schools are running on stranded assets and investing more and more in those assets. Investing more and more. In the last year, in the last 1 year, $150 billion were invested in new fields to replace the reserves. And if we burn those fields, we've completely overshoot the carbon budget. I didn't hear much the discussion about the carbon budget, but Kieran mentioned it briefly. The carbon budget is what we can still burn in order to maintain the Earth system in an inhabitable situation. It's an incredible research. There have been 425 extraction projects funded in the last year. And each one is pumping around 1 gigaton of carbon dioxide into the atmosphere. That makes it around 420 gigatons of carbon dioxide in the atmosphere in the last year. Do you remember how much the carbon budget is? If we have a 50% chance of reaching 1.5, let's say 1.7 degrees, 800. So you might think that you want to reduce your carbon footprint by making a better building. In the meantime, your bank account is emitting more money and more carbon. And this is where really the difficulty lies, because of course architects are rich, and architecture is for the rich. And this is really the moral difficulty of dealing with architecture in the Anthropocene. Between 2016 and 2022, $1.8 trillion have been invested in fields that you cannot burn, except that they're already being burned. And it's not only oil, it's coal in China, new coal in Poland, new coal in India, in Brazil, plus oil, plus gas. So when you're thinking of your incredible interface between the oil field and the economy, which is the refinery, try to remember that the conditions through which oil is dangerous, it's because it produces an economy that is dangerous. It's volatile. It's so thin, so stretched out that it's gone beyond any capacity of recovery. And the Museum of Oil for us is really an attempt to create a moment of public reflection on this and trying to then operate as a sort of an institution in the making that tries to bring all the differing opinions, because we cannot just simply pretend that we are not going to have an economy. that we're not going to have hospitals, that we're not going to eat, that we're not having schools. But we need to exit from oil. And the danger is not in the transition, we might not have renewable energy. The danger is in no transition. The danger is already there. It's called inflation. So the Museum of Oil is also interesting, maybe spatially because it looms on you, but it doesn't actually fall down on you, which is an inversion of the topical notion of the sublime. So we shall need to keep oil in the ground. That's the Museum of Oil. Ooh, I'm running out of time. Oceans in transformation. At the opening of Oceans in Transformation, Francesca Thyssen-Bonamizza came to us and said, hey, it's interesting, can we do something like this about the oceans? And so we started working with Francesca, who is a fantastic philanthropist. She is the most prominent art collector, contemporary art. Her family has a long history of art collection, the most interesting of the private art collection of the monarchs. And so we worked with Thyssen-Bonamizza, Art Contemporary, TBA21, the Academy, in helping them changing the way in which they operated and established a new space for advocacy to safeguard the ocean and to transform the operations of TBA and helping them bring about what is called Ocean Space, which is a large organization with headquarters in Venice, in the former Church of San Lorenzo that you saw quickly. And the project is organized very quickly by saying that if you want to safeguard the ocean, you really have to quickly transform the images of the ocean. You have to transform the image of the ocean from that space that is opposite to city, that is opposite to the territories of industries. No, it's the untamed nature, the blue, the deep blue, where you can go and immerse yourself in the coral reefs. But you start to build, you have to start building an image that is disquieting about the ocean, that is an image that is complex, and it's the Anthropocene image. It's the Anthropocene ocean. And the Anthropocene ocean is composed by these dynamic data sets, and there's hundreds and hundreds of data sets that come from across, all publicly available. It's important that this is always publicly available information, also in the Museum of Oil. We collect all of this information, we start talking to all the scientist groups, and then we discover that the information doesn't overlap. Now, we all know that it's one ocean. We all know that it's one global ocean, but no. One drop of water goes from the Atlantic Ocean to the Arctic, to the Pacific, to the Southern Ocean, to the Indian Ocean, to the Pacific. It's one. But suddenly we discover that it's multiple. The ocean is multiplying because every interest groups, artists, fishermen, scientists, politicians, are each one projecting onto the ocean a partial image. And when we bring together all those data sets and we create these images in a space, we then bring the scientists back, or the activists back, or the communities of, we call them primordial futures community. We don't like to call them indigenous communities, but we bring them back, and then we start asking them to describe what they're seeing to each other. And then they start talking about the ocean rather than talking about it. And they start developing new languages, new ways of operating. This is really the construction in common that is possible through an architectural approach. And these are then organized through trajectories that connect tipping points of the Earth. I think Mike Weinstock yesterday showed you a little image by Tim Lenton of the multiple tipping points of the Earth with tipping points of world systems. So, for instance, you go from the deforestation of the Amazon and you connect that to the warming of the Gulf of Guinea with the growing temperatures in the mid-Atlantic that are connected, of course, with the triangular transportation of the economy in the colonial times, with slavery. And suddenly you start seeing things that are impossible to usually imagine only in the science world of climate change. You start seeing that the connections are really deep, they're lasting. It's structural conditions of center periphery, of exploitation. So the greening of the sub-Sahara, which has got to do with the fact that the ocean is warming, it precipitates more and there's more possibility, is stopping the sands being blown by the winds across the ocean, fertilizing the ocean, fertilizing the Amazon, and ending in the Galapagos. And all of that is what we describe. And so you start connecting the abstract notion of the Earth, this new figure in the making, with historical condition. And the historical conditions are then mobilized by different activists and different groups. Here you see Chile and the phenomenal discussion about deep sea mining and the transition to renewables with lithium mining, or sea level rise in the metropolitan coast of Asia, from Strait of Singapore all the way to the Bering Strait. And what you start seeing is really that the Oceans in Transformation is like a crazy project of Territorial. I don't think we'll ever do such a monumental project again. It's too much. But the amount of information is really interesting, because all of this is then made available to everyone. And you can repeat. If you want, you can build it yourself. All of this is based on open access data. There's no such thing as open data in science. But it also mobilizes other projects for us. For instance, a new project is about how to shape the possibility of having democratic control on environmental data. How do you create that? And we're working on that with the EIT, which is the European Innovation Institute, which is a part of the European Commission. And the questions here you see is sea level rise and overexploitation, overfishing, and sea level rise is a very difficult thing to discuss. Let me skip ahead if I can. No, I didn't manage. Yeah. Oops. Now, carbon goes into the atmosphere and traps energy. It's a phenomenon that was discovered not far away from here, in London, the possibility of understanding the greenhouse gas effect. Now, there is a situation, you know, in 2015, we signed the Paris Agreement. And the Paris Agreement makes every nation voluntarily control their emissions. Now, if we are all good boys and girls, and we manage to meet the minimum requirements, 2 degrees, there's enough energy at 2 degrees to make the horizon of the sea swell in the coming 100 years, well beyond 1.5 meters that is at the end of the century, but to reach around 3.6 to 4.2 meters. This is Shanghai. Currently, in the areas that will be underwater, live around 450 million people. Around 1 billion people currently depend on the areas that will be underwater. What we're describing is, when we started doing this, we were shocked. Now, we projected onto San Lorenzo this light. And that is our goal. If we meet the Paris Agreement, we'll have to move all the artwork from Venice. We'll have to retreat. will have to completely change. But what is interesting is really that the structures of sea level rise will impact, namely, what has happened in the last 30 years, the rapid urbanization of the planet. This is Houston. In blue, you see everything that has been built in the last 15 years. And in this white shade is the waters impinging on it. In the last 30 years, and we were shocked when we started doing this, in the last 30 years, we've urbanized. That means we transformed humanity. We used to be a species equally distributed around the planet in temperate zones. Now we are mainly a coastal species living in high-density architectures. And architects built it. We built it all in the wrong place. And we have now 30 years, if we are lucky, to decarbonize. And this is really maybe the architects in us. So this is the moment when you have to start thinking. We have 30 years to decarbonize. In the last 30 years, we created a mess. Let's imagine that we didn't know. Let's pretend that we didn't know that we made a mess in the last 30 years. But in the next 30 years, we cannot pretend that we didn't know. From now on, we have to rebuild the relationship to the coast. And this is an incredible opportunity. First of all the architects will have a lot of work. Now, we call this project the sensible zone. Now, the sea level is really a very complex entity. It's the interface between the water and the sky, between the ocean and the sky. And it's rising quickly. And between the water and the land and the atmosphere, there's incredible life circulation. It's really, now every second breath you take, the oxygen comes from life in the ocean. Not anywhere in the ocean. It comes from that little thin area that we call the sensible zone. It's a term that we are developing from Territorial Agency with Sciences. It's the area that connects minus 200 meters, where you can still have photosynthesis, to plus 200 meters, where you have all the stuff, the 30 trillion tons that we've developed. The majority of it is on the coast. And the structures in that minus 200 to plus 200 are to be completely rethought. So far, the way that architects, engineers, and planners try to think that is by keeping it dry, except that you move it a little bit. You keep still a separation land and water. You build a dam, you construct a little bit higher, but separation is clear. We are going to be underwater. We have to reconsider completely those structures. What is interesting about that area is that it's the most sensitive component of the Earth. There, little perturbations have incredible repercussions. It's where life creates the conditions for clouds, that creates the coverage that keeps the Earth cool. It's also the area that is the most sensed by remote sensing and by the entire structures of the production of earth science. So we have to, and this is the proposition, rethink the rapid growth. For instance, this is growth of sea level in the last 30 years, 10 centimeters, in the next 30 years, 20 centimeters, and then 30 years after that, almost a meter. It's going to grow quickly. But in that area, in that little area, is where we can seriously begin working by completely changing the relationship between humans and other entities, becoming sensitive to the technosphere. This is, for those of you who are interested in population growth, from 1850 to 2000, population growth connected to arable area, wheat yield, rice yield, irrigated area. You see, we are running out of space. We don't have space. We have to rethink, we have to recombine completely. Sensible zone is an opportunity to rethink where to operate. And the idea is to operate where we can recycle the technosphere, where we can use the technosphere to recycle the biosphere to recycle the technosphere. And how does it recycle? It transforms carbon into oxygen through photosynthesis. And the cycles are really complicated, and they all happen in those 200 meters. The majority of photosynthesis happens in those minus 200 plus 200, maybe 150, 100, 200, we don't know. It's a proposition, it's an architectural proposition. Oxygenic photosynthesis, photochemistry, of course. The recycling biosphere takes different forms. It can be oxygenic photosynthesis or anoxygenic photosynthesis. Anoxygenic biosphere recycling it's fueled by hydrogen. The oxygenic is fueled by iron. And it really has to do with this weird new Earth, which is extremely sensitive. And we think that this is where we can start coming back to our senses and become sensible to the conditions of the Earth, and maybe become sensible in what we're doing. And the conditions that we try to operate when we think that the areas to tackle are just that thing is an architectural proposition. It's a plan, maybe it's the new city. We think it's a cosmopolis. And all of this is documented in a little book that is in the library, and you can research more on it if you want. You can come and visit us. The project of Oceans in Transformation and the Sensible Zone are commissioned by TBA 21 Academy. We got the STARTS Prize, which is Science, Technology and the Arts. It's a prize of the European Commission that rewards innovation in the art and society. What I showed you today in the second part are new tools for diplomacy, and that is what we have to offer as territorial agency. It's with a warning, the danger of neat identifications. Don't think that you can be sure what you are dealing with. The Earth is sensing and is behaving against us in all kinds of ways, and we hope that it's for climate peace or climatic peace, where we can recompose a city so that we can have all species finding a way of being together with one another. And I think that there's urgency for peace. Thank you.